Assalamualaikum and hello. So for today, we will continue our study in chapter 7, which is graphic. So graphic, basically, you have the data, you convert it into figure. Okay, you have X plot and Y plot. So our focus or our objective for today is you will learn about two-dimensional plot, okay, and you also learn about subplot, means that inside a figure there are multiple plot. And also I will show you some specialized 2D plot like discrete graph, log, and histogram. So polar and bar graph will not be covered here. Okay, so you can learn it yourself. It's not too hard. Okay, and also I will show you how to edit figure using wizard, which is one of the function inside the MATLAB. Okay, we start with the introduction. So what is plotting? So I think all of you know what is plotting. Basically, you have a lot of data, and if you look the data inside a table, you cannot see the relationship. So basically, when you do the plottings, much more information you can extract from the figure. So that's why we do plotting, especially in engineering, okay, or science. Anything, okay, anything that including the that have data. If you have plot, it is much easy for you to analyze the output. Okay, as I mentioned before, anything that you do for science usually have scientific data. So this data you have to collect, okay, many samples, and it will be formed in form of vector, okay, a long chain of data. So that is why, okay, that is the first thing you need to know. You have to collect all the data. Okay, here are some example of the data. Okay, so you have data temperature recorded from 0.5 second until 1 minute. So the measurable variable is the temperature. So function variable or x-axis, okay, the temperature is y-axis, function is x-axis. So the output is temperature, the input is the time. So basically, because you want 0.5 second for 1 minute, okay, so 0 step of 0.5 until 60. So basically, the number of sample is 121. Okay, just a quick fact that when it comes to scientific data, make sure that the x and y is the same number. Okay, if you have 121 sample, okay, input, you need to have 121 sample output. Okay, same as here. Voltage output of RC circuit for 20 value of often range between 10 Hz to 100 Hz. So you want 20 value, so I suggest you use line space. Okay, for the first one, it use a step of 0.5, so that you use this approach. Okay, and okay, so you use this approach. But if you have you want a fixed number of value, for example, if you want 20 value, I suggest you use line space. Same as here. Okay, okay, if you want a 10 different input, you just use line space. Okay, if you want, okay, Hertz capture at 200 sample per second, means that this is a frequency, so you just 1 divided by 200, which is the step size, until 1 minute, which is 60 seconds. Okay, and the sample much more larger, something like this. Okay, this one also the sample of data. This one I think you know. Okay, when it comes to plotting data, x-axis is usually the input of the function, and y-axis is the measured variable. Okay, so you have x and y. Okay, so basically x is the, if you remember the basic signs, is the manipulated data. So you set the data. But y-axis, okay, this is y-axis, this is x. Okay, this is y. Okay, y-axis is the measured or output. Okay, so make sure you know what is the difference between x-axis and y-axis. So we continue with our next part, which is 2D plot. Okay, you can plot many form. Okay, usually MATLAB support until, if not mistaken, 3D or more. I'm not sure more, but usually I only use 2D and 3D. Okay. Okay. To do plot in MATLAB, you only use this code. Okay, easy. Just write plot, and inside there you put the x data. Okay, you have x variable, you have y variable. This one is the setting. Okay, for example, you want the continuous line, you want a dotted line plotting, or you want the x plot. Okay, just a point x or plus plus plus. So that one you set it here. So that's it. So, and make sure that the data here has the same number. Okay, if x has 100 sample, y needs to be 100 sample. If not, it cannot be run. Okay, make sure you try this. Okay, example 7.1. So you have y is equals to exponential x divided by 2, and x is 1, 2 until 10. Okay, how to do this? First, because this is only one step, so x is 1 until 10. Okay, that's it for x, the input. Then for output, you just use this. Okay, exponential x divided by 2. Okay, try it. And you have x data, you have y data, then you plot it. So you get this one. Okay, so you can try and you will get this data. So this is the x data. Okay, you can see it from 1 until 10. And for y, it is the result of the equation. Okay, another thing that you need to know, for example, if you only insert one data, something like this, okay, the MATLAB automatically know that the only one data is the y-axis. Okay, you can see it here. Okay, automatically the same. So if you look here, x, okay, this one is the original. If I run it, also the same. So automatically MATLAB will assume the x will start from 2. But what happen if the x is start from 1? But what happen if x is start from 2? Okay, you will get the answer something like this, start with 2. But if you start with 2 and your plot data is not step by 1, you cannot use this one, because it's automatically assumed that your plot start with number 1 and the step is 1. Okay, if I run this, okay, this is the original, start with 2. Okay, it will go something like this. Okay, it will start with 1, and you change it, for example 0.1 step. Okay, only you plot x and y. Okay, you can see something like this. Okay, so we start with this one. Okay, but if you don't include this, it will not stop with 10. Okay, if I run this, it will start according to the data location. Okay, so make sure if you need to put x, put x. If don't need, no need. Okay, but this one is not important. I suggest you just put the x value automatically. Okay, easier. Okay, by default, if you just write plot open bracket x and y close bracket, the MATLAB will automatically choose the color and the line type. The default line type is the solid line, which is the default, and usually the color will start with blue. Okay, blue, or I think blue. Okay, so we start with blue. Okay, and then red, if not mistaken. So if you don't give any information, the MATLAB will automatically just plot it with the default setting. But if you want to change the plot, okay, you can change it to if this one is default, this one can be a dash line, means that dash dash dash. This one is the dotted line, or this one is dash combined with dot. Okay, this you can adjust it at the third part. So remember that you have, okay, you have plot, open bracket, you have x data, y data, okay, you have line, okay, this one is the spec, right? So this is the line plot spec, you put it here. For example, you want to be a dash line, okay, so you put dash, okay, and if you want dot dot line, so you replace this with dot dot. Okay, you also can change the color. Okay, if you, for example, your plot want to be green, you put, okay, for example, you want to be a dotted line with the green color, so you just write plot, okay, plot, so the x, y, and then don't forget open bracket, okay, double dot, and then g. Okay, the MATLAB will automatically know that you want a dotted line with the color green. Okay, for example, if you don't want if you want your plot to include the marker, okay, you also can add this. Okay, for example, you have plot like this, okay, you have, for example, something like this, and you want to have a marker, okay, so you just put, for example, this one you want to be a cross, here you just put x, g, x, okay, you just include these three variable. Okay, for example, if you want circle, so you just put O. Okay, that is how you change the plot specification, line specification. Sorry, my PC hang. Okay, now try example 7.2. Okay, almost the same. Okay, but this time you add this. Okay, the line specification. So you see here, this one is the line. Okay, the line, normal line. Okay, then M is the main data, okay, and O is the circle. So you can see here, this is the result. Okay, this one I already explained. Okay, why this one is not work if you only plot Y. Okay, one, because the data is not step by one, and don't step by one. Okay, and one more thing is you include the spec. Okay, line spec. When you include the line spec, you cannot plot only Y and line spec. Okay, usually cannot. Okay, so make sure you include X. So you can see here, if I run this, okay, you can get this plot. For example, you want a dash line. Okay, this one is a solid line, so just put double. Okay, and will something like this. And for example, you want dot dot line, dotted line. Okay, run it, you get dot line. Okay, so combination I think is something like this, right? Okay, oh sorry, dot. Okay, so let me check first. Okay, I don't remember also. Oh, it's flip. Okay, you will get dash and dot. So you don't want magenta, you want green, G. Okay, it will show something like this. Okay, what else? Black is K, so we get something like this. Okay, you don't want 0. Okay, you want X. Okay, get something like this. And if you want, for example, diamond, okay, so change this to diamond. Okay, you get diamond. Okay. Okay, when I run this, it will not go out because the old figure is replaced with the new one. It will not be closed. That's why it will not pop out. Okay, if you close this, then it will pop out. And if you don't want something like that, or you don't want to mess with the figure, I suggest you write before the start. Okay, you write close all. Means that you close all the figure. So means that if you run this, automatically it will close the figure first, then it will, when you run, it automatically pop up. And the previous data will not compromise your current, your previous plot will not overlap with your current plot. Okay, this is important. Sometimes you want to overlap, sometimes you don't want. So to avoid this, you use close all at the beginning. Okay, just a safety tip. Okay, so next part I will show you what is plot formatting. Okay, so this is what many things that you can do on the plot. So the title. Okay, if you want to add title, use title code. Okay, title is basically you write title and then open bracket, okay, apostrophe, then write the title and close bracket, apostrophe, close bracket. Okay, you can write the title of the plot. And then you have X label and Y label. So this one is just the X axis label and Y axis label. This one is legend. Of course, you know the legend. Okay. So legend, if you have multiple plot, okay, inside the graph, you can use legend to differentiate between plot. Okay, you can add text. This one is just you want to add some text inside the plot. Okay, X lim, Y lim. This one you want to set the limit. Okay, for example, you plot the data is very large. You want to zoom and at the certain X axis, so you use X lim and Y lim. Okay, axis also the same thing, except it will cover X and Y axis. So grid, of course, you want to add grid. Okay, and so on. Okay, figure means that you create a new figure. Subplot, okay, subplot means that you create a new the same figure, you have multiple plot. I will show it to you later. Okay, I will show you to at next slide. Okay, make sure you try this example and send it into e-learning after complete the class. Okay, this one is the X data, Y data. This one you're already familiar. And then you plot this. Okay, so you can also you can divide it inside the plot. So divide by pi. Okay, you can also do this. Okay, and then this one is the new thing, the plot properties. So you can see the X label. Okay, so X labels means that this label. Okay, and backdash omega. Okay, for this case you don't have to use, okay, the hexadecimal. Last time we learned about the hexadecimal. Okay, that this time you don't have to. Only you have to check the code for each symbol. For omega W, this is the just backslash right omega. Okay, and don't forget this. Okay, open bracket, close the apostrophe. Okay, so automatically we create this, and then you can create a Y label here. Okay, so Y label sign omega. So this one. Okay. Okay, for XT format, I will show you after this. Okay, I will show you demonstration. And for title, of course, this is the title. Okay, so the title, it will place at the top, and also grid on. So basically, if you want this grid, okay, you have to use grid on. Okay, okay, this is the code. Okay, I copy into MATLAB. If I run this, okay, the original code, this one. So if I run this, you can see here, this data is 2 decimal point, and you have pi here, right? So this one is represent as pi. Okay, so you use this one is pi. Okay, and this one is the percent number. You have to refer back to the f print f. Okay, dot 2 means that it will take 2 decimal point. So if you want 1 decimal point, you just put 1. Okay, something like this. Okay, so the next part is multiple plot on a single graph. So you have, if you want multiple plot inside a graph, you can use the same thing, plot. Okay, but instead only x and line specification, you have to add additional data. So x number 2 and y number 2, line specification data number 2, and so on. So you just add the variable, the 3 variable, and then next 3 variable. So this is one set, this is one set. So you just separate it using comma. Okay, so simple. Okay, if you want multiple plot. And also when it comes to multiple plot, you need to have legend. So how to do the legend? So you just write legend, open bracket, don't forget this one and this one for the first legend, plot legend. Then comma, open bracket, and so on. And don't forget the close bracket. Okay, so I will show you the example. Okay, here for example 7.4, don't forget to do this. Okay, and submit it in e-learning. Okay, in e-learning, okay, you have two polynomial, okay, f and g, this one. Okay, you want to plot the data for x, which is the input is -10 until 10. Okay, with the step of 0.5. So first you have to input it. Okay, set the input and the equation of the output, and of course because this is a vector, okay, if you plot it, you should see this is a vector, you have to do the array operation which has dot. Okay, this one also has dot, so be careful, refer back to your chapter 3. Okay, 2 and 3. Okay, so how to use this data? Of course, x, then f, which is the y, and this is the setting for the f plot. Then you have to write again the x, which is this one, the second plot, and the characteristic of the second plot. And then of course you have to put the legend. Okay, when it comes to multiple plot, of course you need to put the legend. Okay, and x label, y label, you can put it. Okay, grid, usually you have to put grid on a id on. Okay, grid space on. Okay, if you originally if you plot, there will be no grid. Okay, you have to put grid on. Okay, the result will show something like this. Okay, you have first plot, which is the f, and the second plot, which is g. Okay, this is f, fx and gx. This is the x. Okay, make sure you put the label in your tutorial. Okay, how to do this? X label. Okay, and then open bracket. Okay, don't forget that. And then don't forget the y axis. Okay, for this case it doesn't put y axis. Maybe you just can put value just for you to try. Okay, y axis, then put it is value. Okay, right here, that's why you do plotting, because you can detect the two polynomial intersection, which is this location. Okay, so if you look at the data, it's quite hard to determine the intersection point, but if you plot it, you can see the data. Okay, next part is the subplot. Okay, if you don't want multiple plot inside a plot, you want a multiple, the plot needs to be different location, so you can use subplot. So basically the subplot is, okay, if you have, for example, if you want to use it, you use subplot this one. M is the number of row, N is the number of column, P is the position. Okay, so I will show you what is it letter. Okay, so basically M and N is the size, and P is the position. Okay, and the position is the first row first. Okay, I show you here For example, you have a plot here, a figure. So for example, you have 2, 3. So means that you have 2 row, 3 column. So what it will show is 1, 2, 3. Okay. If for example this one is 2, 3. So you have 2 row, 3 column. And for position, okay, here, okay, if you set this to 1, okay, this is 1. This is 2. This is 3. Okay, after complete the first row, this is 4, 5, 6. It's something like that. Okay, it is the opposite of linear array. So linear array is go down first, right? But for subplot, it will go to the row first. Okay. Okay. Try example 7.5. Basically, you have two plot. Okay, this is the x-axis, the input. This is the y-axis. Okay, you have two y-axis, which is y and z. And you want to plot with the two different plot. And you can see here there are 2 row. Okay, this one represent 2 row. And make sure this one, the data is the same. When you use plot, subplot, make sure the first one and second input is the same. Okay, 2, 1. So 2, 1 means that you have the plot. Okay, you have a figure there. You have a plot something like this. You have 2 row and 1 column. Okay, position 1 means that this is the position 1. Okay, this is position 1, and then this is position 2. Okay, after you do the subplot, and then you can write the plot. Okay, basically you have to subplot first, and then you plot the data. Okay, like before. It will automatically goes inside here. After you write the other subplot, then it will go to the second part. Okay, see, this is the example of the result. So in your tutorial, make sure you include the title here. Okay, this is the title, and X label here. Okay, I think Y label just either you can put value, okay, or magnitude, or just leave it blank. Okay, so make sure you try this, and this is the result of subplot. Basically, you have a figure here. Okay, you have a figure. In that figure, you have two plots, 1 and 2. Okay, let's try another example of subplot using RC circuit with variable AC input voltage. Okay, you don't need to understand too much about the problem, but you need to understand how to solve it using coding. So you can see here, this is the problem. Okay, basically you have the output is hash, okay, and your frequency is F. This is the input. So you varies the frequency. R and C is just constant. Okay. So this is how to get the magnitude. This is how to get the phase. This is basically control. Okay. I think you're still not learning this. Okay. I'm not sure whether you're learning it or not. Okay. So this is second order if not mistaken. Okay. But in MATLAB you don't have to do this. Okay. You don't have to write the equation for phase and angle. So you can just use this Fs and hash and angle hash. This is the hash. Okay. So it is easier because you don't have to write the equation here. So automatically. So basically you have to create a frequency from what to what, and then you include into the equation. Make sure you use array operation because you have multiple value of F, and then you use absolute here and angle here to get the output. So F is the input. Okay, so the constant already given here, C. Okay, and the frequency is from 0 to 10 kHz. Okay, from this problem you can see here, this is the constant. Okay, this is the input from 0 to 100 kHz, 10,000 kHz. Okay, this is the equation. Of course, you remember you have to use the array operation. Refer back to the previous chapter. Okay, what is array operation is, and then this is magnitude and phase. Okay, so remember this is angle. Okay, this is absolute value. So you want to plot two graph. Okay, and this is 2, 1, 1. Okay, which means that you have something like this. you have 2 row, okay, 1 column, and this is position 1, of course, at the top. Okay, remember it will move like this first and then move this. So this is position 2. Then you have to plot. Okay, plot F divided by 1000 because you want to be the unit is kilohertz. Okay, this one is hertz as Z. This one is kilo as Z. And then of course you plot the magnitude here, the phase, magnitude and phase. For phase, you divide by pi. So basically you want to remove the pi. Okay. So then of course you have to label it properly. X label, X tick. Okay. If you want to include unit here, K has Z. Okay. And 0 F means that here 0 F means that you don't have you don't have the decimal point. Okay. And magnitude. And then same as here, this one you don't have a decimal point. Okay. And you have K has Z. Okay, same as here. This one, if not mistaken, is angle x3c0. Okay, so of course remember the hexadecimal. Okay, in X label you can use the backslash omega. Okay, or backslash any written part, but for tick format you'd have to use hexadecimal. Okay, so be careful too. So you can see this is the result. So you can see there is no decimal point here. Okay, and you have a frequency label, phase, magnitude, and the Y tick you can see here. Okay, 1 decimal point. Okay, and you have pi here. Okay, make sure you know how to manipulate the X tick format and Y tick format. Okay, if you want to put something here, okay, make sure you know how to do it. Okay, I give you another subplot example, okay, which is quadrant. Okay, so for this case, the time is constant, but your subplot is changed with 4. Okay, using for function, okay, you change the location here. You can see here, subplot you have 2 multiplied by 2. You have something like this. Okay, you have 2 multiplied by 2. Okay, 2 row 2 column. And of course, changing of this one is like this. So 1, 2, after complete it, you start with the second row, 3, 4. Okay. So each plot will plot this. Okay. But for each plot, F increasing. So because of the 4, F is increasing. So basically the frequency, okay, or the radian or angular frequency, I think, angular speed or angular frequency, okay, is increasing. Okay, the first one is just 1, then 2 pi, okay, 2 pi, 2 pi, and then 4 pi and 6 pi, something like that. Okay, the time is consistent. Okay, and then of course you plot the x, the t and y, and you label it properly. Okay, y string f print f. Okay, so this one I will show you after this. What is this done? Okay, okay, y label. Okay, so I will show you after this. Okay, of course the title is this one and the title. Okay, so and okay, so I copy back this coding and run it. Okay, it will produce something like this. Okay, so you have the first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, as you can see here, the cycle increase value. Okay, why you have to do this sprintf? Remember the sprintf before? Okay, so because your title changes. Okay, because your title changes, you have to use fprintf or sprintf. So basically for your y label, okay, you can see here, this is 1, this is 2, this is 3, this is 4. So your y-axis is changing, and of course the the title also changes. That's why you have to use sprintf sign this one, and remember the percent decimal f. So the percent decimal will place here. Okay, your f will be placed here. So same as here, this is for the title. Okay, so f is written here. Okay, because you have variable inside here, that's why you have to do this coding. Okay, and the output will be something like this. Okay, okay, this is the figure. I just copy the figure to the slide. Now we move on to the next part of the study, which is spatial plot. So basically, your plot is basically a linear plot for x-axis and y-axis. This is just a standard if you use plot. But there is also a spatial plot, okay, available in MATLAB, others than the normal plot. Okay, the first one is stem. Okay, the stem is basically almost the same. Okay, you need to have the x data, y data, and the line specification. Okay, but the stem is for discrete graph. Okay, I will show you after this. Okay, so you start with the discrete signal. Okay, this is the example. Try it. Example 7.8. So you have to plot a discrete signal. Okay, sine wn, n is equal to this one, and w is equals to this one. Okay, so of course you place the constant inside here. Okay, and the variable here, and then you plot using stem. Okay, n is the x-axis, y is the y-axis, and of course you have to label it. Okay, this one also I already show you how to label. And for this one I will show you in the demonstration. So of course I copy back this variable. Okay, and this one, okay, you can see here t string. Of course this one is just a variable as printf. When it comes to variable title, okay, you look here, discrete signal, and then remember dot dot dot. This one is basically not creating a new line. It's just a continuity, because for example, if your coding is your writing is too long here, you don't want to be very long, but you want to continue writing, you just put triple dot. Okay, remember last class I show you here. And for this one, of course, the hexadecimal for omega equals to percent dot to means that 2 decimal point here. F is the floating number, and of course this one is the, if not mistaken, is the pi, if not mistaken. Okay, so W here, okay, it takes the value of W and remove the pi. It's basically you want to this value, and then this characteristic is placed inside the title. Okay, if I run this, so you get something like this. So stem is the discrete plotting. So basically it's not continuous, it's just plot one by one. Okay, and this is the title. You can see here it will take this value. Okay, so you can see it is discrete. And how to save this? You just go to edit, copy figure. Okay, you copy the figure, go to, for example, you want to place it in Word. Okay, and then just right click and paste. You will get the high quality image. If you can see here, you can zoom in. Okay, the quality is still not changed. Okay, for example, if you want to adjust the size, don't adjust something like this, because the numbering is much more smaller, so you adjust here in this format. Okay, so I give you something here. Okay, I adjust it for a more smaller. edit, copy, and Control V. So it is much more larger. Okay, you can see here the numbering, the label will be larger. Okay, or if you want to save it, just file, save as. Okay, you can save it as MATLAB figure is just a figure in the MATLAB format, or you can save it in the JPEG. Okay, JPEG or PNG. This one is JPEG. Okay, and PNG, where is it? Yeah, this one, PNG. And of course, the highest quality is TIFF. Okay, if you want the figure will be high quality, you have to use TIFF or TIFF no compression image. Okay, but I suggest you use the edit copy. Okay, the quality will be higher. And make sure you go to setting, go to option, okay, and go to advanced, go down. Okay, you can see here image quality. Okay, this one you can set to high fidelity if you want very high quality, but if you don't want, I think 220 is enough. 330 is usually if you want to submit something, it's usually 330. Okay, and make sure you know that higher fidelity means higher number, means that higher size of the file. So this is what happened if I paste the figure inside the PowerPoint. Okay. So I give you example. Okay, example 7.9, which is using the semi-log graph, or if not mistaken, semi-log graph. Okay, loudness. Okay, when it's involved, you can see here you have multiple data and you have a loudness here. Okay, you want to plot in the, okay, you want to plot this. Okay, so this is the code, of course. So L is the magnitude. Okay, and then occasion is the X data. Okay, the input. This is the output. So how to plot it? Of course, L and, okay, the L, okay, and then subplot is, okay, of course you use subplot. Okay, 2 multiplied by 1 means that you have something like this. Subplot this one and this one. So this is position 1, position 2. Okay, this is a normal plot, of course. This one is the semi-log Y. Okay, this one using a normal linear plot. Okay, the range is linear. Semi-log Y means that the y-axis is is the logarithm plot. Okay, and you plot the L value, okay, here and here, and this is the characteristic. Okay, solid line. This one is the blue line and blue color, and this one is the O. Okay, you have O symbol. Okay, tick. It's called tick. Okay, and for this case, okay, X ticks and X ticks label, I will show you in the demonstration after this. Okay, this one also I will show you in the demonstration. Okay, and of course this one you already know, X label, Y label, and title. So I copy the code and I run this. Okay, you can see here, okay, the limitation of linear plotting is that you don't see the data. Okay, if the data is something like this, okay, if I check back here, okay, you can see here, okay, the range of data change dramatically. Okay, so power of 10, power 11, power of 9, power of 9, power of 8, 6, 2. So if you have this kind of data, if you plot it in linear part, you cannot get anything. Okay, it's just nothing. So that's why you have to use semi-log, something like this. Okay, so instead of just a flat line, you can have a different result. Okay, you can see the increasing. Okay, right now the X ticks. Okay, you can see here you have 1, 2, 3, 4, 5, 6. Okay, you want to have 5 tick inside here. Okay, 6 tick. 1, 2, 3, 4, 5, 6. So x ticks 1 to 6. Okay, you have to start from 1. Okay, and occasion you just take this data. Okay, this data you just plot it back inside here. So that is how you want to label it according to this instead of number. Okay, that is how you use to replace the number with the discrete input. Okay, something like this. So this is the result. Okay, so I copy it, save it, okay, and paste it inside the slide. Okay, another important plot you have to do is board plot. Okay, board plot is basically the semi-log x. Okay, the x-axis is the logarithm, y-axis is just a linear. Okay, this one is very useful for signal, frequency analysis. Okay, so this one will be, I think for you will be learn it in semester 3, 2 or 3. Okay, sorry, not semester, the year 2 and 3. So this one, of course, the same example. Okay, so this one is just a standard. For magnitude, we usually multiply by 20 log and the absolute value. Okay, this one taken from example 7.6. Okay, this one the frequency of the RC. Okay, RC circuit. So phase is just leave it there. So you have to plot it in this form. Okay. Okay, and of course you have y-ticks format included here. Okay, this one also I already mentioned it. Okay, try to run this and you can see the result. Okay, so you can see here, this is the board plot. Okay, the semi-log x. So basically the x1 is the logarithm. So 0, power of 0, power of 1, power of 2, power of 3, power of 4. Okay, so the result will be something like this. Okay, and this is the phase. Okay, I think in your semester 3 or 4, okay, you will learn about the control algorithm. Okay, and you have to look at the phase axis and y axis, and you have to use this. Okay, so if you learn this early, you can learn to plot this, okay, in your assignment. Okay, so this is how to do a board plot. Okay, another special diagram that you can use is histogram. Okay, of course the code is just histogram, this one. Okay, so I will show you how to use this. So x is just the data. Okay, this one I will tell you after this. Okay, this one is basically a scala define the custom or number or user define bin, and h is the vector defining the bin h of the histogram. So I will show you the example, you will be understand it more. So remember last chapter, chapter 6. Okay, you learn about input output. XSL read is basically you read the data from the Excel. So for this case, I think you cannot run this. Okay, because you don't have this file. Okay, you don't have this file. So it's okay, just try it. Okay, you run this, you take the data, okay, and you subplot it, of course. Okay, you subplot it 1, 2. So basically you have 1 row, 2 column. So something like this. Okay, and you create a histogram, of course, mark, and mark is from here. Okay, you save the data mark, and this is the x-axis. Okay, the x-axis. So of course you have to label it, the score. Okay, this one, the y-axis, x-axis label, the title. Okay, Okay, this one is also the same. The difference is this one only. Okay, the marking. So for this one is only 0, the step of 2 until 40, but for this one it is less detailed. Okay, 0, 10, 40. Okay, so the result is you can see something like this. Okay, this one represent the step. Okay, the step of data, and this one is much more larger, which is 10. Okay, this is 2. Okay, so I create a data here. You can see here you have a name and score. So I save this file. Make sure the location is correct. Okay, make sure you know the correct location. Okay, some of you cannot run it because you don't properly set the location. For example, I set it in desktop. Okay, the file name is book1. Okay, I run it, and I have to make sure that this one, okay, the address here also desktop. Okay, so of course I save it to book1, okay, dot xls. Okay, you can see it here, okay, at the side. So make sure the name is the same. Okay, and why, okay, this one I delete, and the location is B2 until B14. B2 B14, because this is only one sheet, so just leave it. Okay, so if I run this, okay, you get the data here. Okay, if I show it back, okay, so you can see here the data is from 0 to 40. Okay, and this is the step. Okay, this one is 2, this one is 10. So you can see the data changes for 2, and this one is 10. Okay, so that is how to do the histogram. Okay, now we move on to the last part of the study, which is the plot tools, okay, or wizard. Okay, so instead of using coding, okay, you also can use a GUI, graphical user interface, to edit the plot. Okay, if you don't want to use coding, you can use that, but I suggest you learn how the code also, because in the final it is based on code and not the wizard. Okay, wizard is just to help you in your future courses. Okay, this one already mentioned before, so you can see here, okay, you can adjust anything in the system itself. Okay, the figure. Okay, you can adjust the x-axis, y-axis at this location. Okay, here I show you some demonstration. Okay, I run this. Okay, you get the result here. You can, for example, insert X label. Okay, insert X label. Okay, so input, then insert Y label. Okay, output. Or you can adjust this. Okay, or you can insert the legend. Okay, you can insert legend, and then you can adjust the name of the legend inside here. Okay, and for example, view. Okay, property editor. So you go to here, property editor. Okay, you can adjust the x-axis here. For example, you want to put a title, something like this. Okay, you want to put grid. Okay, x-axis, y-axis. Okay, so instead of using coding, you have the GUI. Okay, so you can change the scale to logarithm, something like this. Okay, or linear. Okay, you want the location axis is on the top or bottom. Okay, maybe at the top. Okay, something like this. Okay, bottom. Okay, you can change the tick properties here. Okay, you want to be automatic or step by step, manual. Okay, everything you want to do, there are menu here. Okay, only you have, okay, font, for example, you don't like this font, change to this one, for example, impact. Okay, and then change the size. Okay, so using the property editor. Okay, and then of course you can save it, copy figure. So we have finished chapter 7. So we can conclude that you have already learned how to do a two-dimensional line plot, how to change the tick, okay, the line type, the color, how to do a multiple plot, okay, inside the plot, okay, and then you also learn how to do subplot, okay. So basically inside of one plot you have multiple, inside a figure you have multiple plot. And also I show you some specialized 2D plot function like a stem, log, a semi-log graph, okay, and histogram. And for this case, if you want to, there are many more plot actually, even animation plot. Okay, you can Google it. Okay, you can try to Google and try to see what plot are available in MATLAB. And of course, and lastly, I show you how to edit the figure using wizard instead of coding. Okay, and make sure this is just for your easy adjustment. Okay, but for final or test, you will have to use the code. Okay, that's it. Okay, and don't forget to check in your attendance. Okay, I might put paste the attendance inside the e-learning, okay, or under the description of the YouTube. Okay, that's it for today. Thank you.